Alright, hi everyone. So here's your first kind of 15-minute revision video, and this one's going to be on straight line graphs, which is obviously, an area that everyone feels like they need to work on. So these are the things that you need to be able to do for your exam, and I'm going to try and cover all of these as much as I can in as little time as possible. Okay, so the first thing you need to be able to do is recognize, sketch, and draw straight line and curved graphs. Graphically calculate and find gradients and y-intercepts. Introduce y equals mx plus c, so that's the equation of the line, and being able to find m and find c, which is the gradient and y-intercept anyway, so we're covering that in the point above. Find the equation of a straight line, including the equation of the line between 2 points, and model situations using graphs. Okay, so we're going to look at all of these things. So the first thing you kind of need to know, I think, is the most important thing, is what actually makes a line straight. Well, a line is straight if it's got a consistent change between the points. So if we look down here at -4, for example, this one here, that point there, that's -5. And I'll see if I can just make this a little bit bigger so you can see it. Okay, so that's -5. Now, if we go along to the next point, which is -3, okay, we can see there that we've got a change in x of 1 and a change in y of 2. Now, if this is a straight line, you should always have a change in 1 for x and a change in 2 for y. Otherwise, it wouldn't be straight anymore. So we can go across 1 and we can go up 2, and that's still a change in 2. We can go across 1, up 2, again, it's still the same change. And that's what makes it a straight graph. Okay, if it was curved, like if it looked like this, okay, you should be able to see that the change isn't the same. Like in this case, when we go across 1, we go up half, but then when we go across 1 more, we go up about one and a bit, about 0.75, about 1, and then when we go 1 across again from here, we're going up almost 3. So you can see that that change isn't the same. So what makes lines straight? A consistent change in x and y values. Now, we've got a special name for that consistent change, and that is a gradient. Okay, the gradient is, in straight line graphs, that consistent change that you see. And you should remember that the way that you find a gradient, you can do two different calculations. The first one is what we call rise over run, and it's kind of like the baby way of doing it. And I don't like that one so much because I think you get stuck with the positives and negatives. The better way of doing it is it's your y2 minus your y1 over x2 minus x1, where y2 and y1 are 2 y coordinates and x2 and x1 are 2 x coordinates. Okay, so we're going to look at that coming down. So all straight line graphs have some features. Okay, the first one is they have a gradient, and they all have a gradient. The gradient might be 0, but they still have a gradient. Okay. The second thing they all have is a y-intercept. All right, and the y-intercept is the point where your graph crosses the y-axis, and a lot of them have an x-intercept too. Now, the only ones that don't have an x-intercept are vertical line graphs. Okay, and vertical line graphs they're like a special case of straight line graphs. So we kind of almost don't really include those in the family, to be honest. Okay, now to form the equation of a straight line, we incorporate those two things that all of the lines have. So because we call our gradient m, we use the letter m for gradient, we call the y-intercept c, and we know that y changes as x changes. So our equation of our straight line is y equals mx plus c. So y is equal to the gradient multiplied by x plus the y-intercept. That's how you find the equation of any straight line. So what we're going to do is we're going to go through and we're going to work out the gradient and the y-intercept just by looking off these graphs here and make the equation. So for this one here, I'm just going to change my color pen for a second. We'll go with yellow. Okay, so for this one here, now you choose your 2 points for the gradient based on where you can see it goes through the corner point on any point of the graph, because you want them to be whole numbers. So in this case, I'm going to use -1. I'm going to use that one that I've already got highlighted there, -1. then I'm going to go across 1 in x, and then I'm going to go up until I find another point of intersection, okay, which is here. And I can see that I've gone from -1 to 3 in y values. So I've gone up 4 and I've gone across 1. So in this case, my gradient is 4 over 1. Okay, 4 divided by 1, which is 4. My y-intercept is -1 because that's where it crosses the y-axis. So my equation altogether is y equals 4x minus 1. Okay, if we look at the second one, now I'm going to do the same thing again. Now you'll notice with this one, the gradient, the line isn't going up from left to right, it's going down from left to right. So that's telling my gradient should be negative. So what I do with this one, I'm going to find a point. So I'm going to use this point here where it goes through 3 and 1, -3 and 1, I should say. And then I'm going to go across 1. And then I go down until I meet that intersection again, and I can see that it meets up at 0, -2. So for every 1 I go across, I go down 1, -1 down. So in this case, and I'm just going to just give myself a little bit of extra room. In this case, my gradient is -1 over 1, okay, that's my, because you always do y over x, so that's y over x, and in this case as well, that's y over x, okay, 4 over 1, so y over x, so -1 over 1, which is -1, and then my y-intercept in this case is -2, so my equation is y equals -1x minus 2. Now, we never write the 1 with the x, so I'm going to change that to -x minus 2. All right. Now remember, with horizontal lines, all horizontal lines have a gradient of 0, okay, because they don't change their y value. The y-intercept is 4, so my equation would be y equals 0x plus 4. Now, obviously 0 times x is just 0, so my solution is going to be y equals 4. The other case where you might have a horizontal line, again, I'm just going to change my color on my pen for this. Again, horizontal lines are kind of special cases because they're actually a different type of graph, but they look a bit like vertical lines. They look a bit like horizontal lines, but they go through the x-axis, not the y-axis. And your equation for any kind of vertical line is just x equals whatever that intercept value is, so -3 in that case. Alrighty, oh, that looks nice and colourful. Okay, so that's how we find the equation of a line from a graph. So remember, you need 2 coordinates to find the gradient. Right, your formula for the gradient is rise over run, or you can think about that as the change in y over the change in x. Okay, so your difference between your y divided by your difference between your x. Your c is your y-intercept, and then you put it all together and you get y equals mx plus c. So that's it there. Okay, we're going to do the reverse quickly. So this is looking at plotting the line of a graph from an equation. So if my equation is y equals -x plus 7, say I want to find when x is -2, my y would be y equals -2 minus 7. Now -2 is +2, minus 7 is -5. So that's me -5 in there. Now for 1, I'm going to have y equals -1 minus 7. -1 is +1, minus 7 is -6. For 0, y equals -0 minus 7. And that's just 0 minus 7, which is -7. Now what you should see here, once you've done a couple of points, you should be able to see the pattern, as long as your points are going up by an equal amount. So in this case, they're always going up by 1. Okay, and we can see here, for each of our coordinates, our y coordinates, they're going down by 1. We're going from -5 to -6 to -7. So my next one's going to be -8, -9, -10. Now the reason why they're going down by 1 every time is because your gradient your gradient is -1. So that's why you've got that constant change, the consistent change, because your gradient is the same. All right. Okay, next little bit, we've got to find the equation of a line between 2 points. So our points are -3 and 10 and 2 and 8. So the first thing we want to do is find the gradient. So we're going to find m, and in this case, we're definitely going to use that y2 minus y1 equation, which is really just the same as doing rise over run, but it's a bit more sophisticated, okay? And it works a bit better in this context. So now I'm going to sub in the points. Well, first thing I'm going to do, I'm going to choose my y2, y1, x2, x1. So I'm going to call this one x1, this one y1, this one x2, and this one y2. Now just remember that the x1 and the y1 always have to go together, and the x2 and the y2 always have to go together. All right, from there I'm just going to sub them in. So y2 is 8, y1 is 10, x2 is 2, x1 is -3. Now I'm going to put that -3 in brackets so that I get my negatives and positives right. Then the next thing I do is 8 minus 10 is -2. 2 plus 3, because then you got the two negatives together, so it's plus 3. 2 plus 3 is 5. So my gradient is -2/5. Okay, then I'm going to sub that, and it's not always going to be a nice number, and that's why I've chosen those points for this. Then I sub my gradient back into my y equals mx plus c equation. So if I know m is equal to -2/5, and that's it there. And then the next thing I do after that is I take one of my other points. I'm going to use 2 and 8 in this case, and I'm going to sub in 2 for x, because that's my x value, and 8 for y, because that's my y value. All right, from here then, I sub this in and I get 8 equals -2/5 times 2 plus c. Now c equals 8. Oh, sorry, I should have, just let me get rid of that for a second. Okay, so now I've got 8 equals now -2/5 times 2. Well, that's going to be -4/5. You've got two lots of -2/5, so -4/5 plus c. And then from here, we're going to add this -4/5 to the other side, because it's negative on that side, so we want to cancel it out and make it positive on the other side. So my c is equal to 8 plus 4/5. And then if you want to, you can even do that on a calculator, because you're going to have one in your exam. 8 plus 4/5. Okay, and that's equal to 44/5, or I could convert it to a decimal, which is going to be, convert it to a decimal. Okay, which is 8.8. So I'm going to put that in as 8.8. Okay, lovely. So now the last thing is you then need to write your equation of your line. So y equals -2/5 x. Now the y and the x now go back in, and all you should be left with is the m and the c in the equation. So -2/5 plus 8.8. Okay, very last bit. Wilf is taking a taxi, so this is modelling using straight line graphs. So Wilf is taking a taxi to Devizes. Taxi company charges him a $2 charge. Now I couldn't get pounds on my Australian computer, but I'll write it in as pounds for you poms. Okay, so he's got a £2 charge, hiring it out, and then for every kilometre he travels, the company is going to charge him $1.50 per kilometre. Okay, so now in this case, when he's gone 0 kilometres, the company's charged him £2. So that would be his y-intercept, because he hasn't gone anywhere, and that's what his cost is. So if you imagine what the graph of this looks like, at x is 0, or at his distance is 0, he's starting at 2. Then every kilometre he goes up by 150, so he'd be up by 150, so that would be 350 there, because it's 150 up, and then he goes up by another 150, etc. So your gradient in this case is 150, because that's what's changing every kilometre. Okay, so we could make an equation now. We could say the total cost is equal to 150 times by, I'm going to say x for distance, plus £2. Okay. All right, I've got 10 seconds left and then this is going to cut off. Go on and do the accompanying worksheets, and I hope this helps. Let me know if you need more. Okay, bye.